All right, so this is the Chapter 1 quiz for Math 125. Number 1, consider the following. The limit as x approaches 6 of the absolute value of x minus 6 over x minus 6. We want to use the graph to find the limit if it exists. So we're approaching 6 from both directions. You notice that it's going to two different locations. If we're going to two different spots, then that limit does not exist. Number 2, here we're approaching negative 6. So as we approach negative 6 from the positive side, you can see we're going to positive infinity. As we approach it from the negative side, you can see we're going to negative infinity. Two different locations. Once again, does not exist. Number 3, we want to find the limit L and then use the epsilon delta definition to prove. So we know we can just plug it in. So we get 5 plus 5 equals 10. I don't know why this is red. Let's get white. So that gives us that L equals 10. We know our function is just what we're taking the limit of, and our C is what we're approaching, which in this case is 5. So the absolute value of f of x minus L is less than epsilon, when the absolute value of x minus C is less than delta. So can we find a delta such that all of this is true? Well, we plug everything in. We get x plus 5 minus 10 less than epsilon. We get the absolute value of x minus 5 is less than epsilon. Over here, we get x minus c, which is x minus 5 less than delta. These are the same, therefore our delta equals epsilon. And we have proven by the epsilon delta definition that there does exist a delta that makes that true. All right, number 4, finding the limit. This is a polynomial. All we have to do is just plug it in, right? Negative 4 squared is 16. We like that kind of problem. Number 5, same deal, polynomial. We can just plug it in. 4 times 0 minus 1, 0 minus 1, we get negative 1. Finding the limit here, we've got the cube root of x plus 41. We just plug that in. We get the cube root of 84 plus 41. That is 125. Cube root of 125 is just 5. Number 7, find the limit if it exists. So what happens if I plug in 0? I get 0 over 0 squared minus 7. I still get 0. So this is an indeterminate form. So that means that I can't do that. So I need to do something here. So notice that this is the same as x. If I factor the x out of the bottom, it leaves me with x minus 7. So we can cancel the x's out, and we get the limit as x approaches 0 of 1 over x minus 7. Now I can plug the 0 in, and I got 1 over negative 7 or negative 1/7. Same deal with number 8. We have to start by factoring, because if I plug in 4, I just get 0 over 0. So I've got x minus 4. Here we have x squared minus 16, which is x minus 4 times x plus 4. The x minus 4's cancel out. I have the limit as x approaches 4 of 1 over x plus 4. Plug the 4 in. 1 over 4 plus 4 is just 1 over 8. And then the more complicated one here, finding this limit. Here, if you plug in 3, you're going to get the square root of 4, which is 2. Minus 2 is 0 on the top. 3 minus 3 is 0 on the bottom. So it's an indeterminate form. So remember, anytime you've got a radical that you want to get rid of, we can do what's called rationalizing the numerator. In this case, because that's where the radical is. So we're going to multiply by the square root of x plus 1, and instead of minus 2, it'll be plus 2. This is the conjugate. And anything we do to the bottom, we have to do the exact same thing to the bottom. So this is going to give us the limit as x approaches 3 of this. So remember, when we multiply conjugates, right? A plus b times a minus b, that's just a squared minus b squared, right? That's the difference of squares. So we're going to square the first term, which is just x plus 1. We're going to square the 2, which is a 4, and we're going to put a minus sign. And then on the bottom, we're going to have the x minus 3, and we're going to have the square root of x plus 1 plus 2. Now what happens on the top? You can see that that's just x minus 3. X minus 3 times the square root of x plus 1 plus 2. So the x minus 3's will cancel out, and it's important to have those parentheses for accuracy. So this is going to be the limit as x approaches 3 of 1 over the square root of x plus 1 plus 2. Now we can plug that 3 in. We get 1 over the square root of 3 plus 1 plus 2, 1 over the square root of 4 plus 2, which is 1 over 2 plus 2, which is 1/4. Number 10, we want to look at this function, f of x equals 9x plus 7, and we want to find the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. So, I'm going to start by doing just a little substitution. I'm going to make this little delta x equals y. And I do this because sometimes people get really confused by all these x's floating around. So this is going to become the limit as y approaches 0 of f of x plus y minus f of x over y. Now over here, I'm going to say, okay, what's f of x plus y? That just means plug x plus y anywhere there's an x. Okay, which is going to be 9x plus 9y plus 7. All right, so then what is f of x plus y minus f of x? Well, that's 9x plus 9y plus 7 minus the original function, 9x minus 7, which is 9x plus 9y plus 7. Distribute that minus sign, minus 9x plus 7. The 9x's will cancel out. That's a plus 7. I jumped the gun there. And how did I recognize that? Because I know that all of these should cancel out and leave me with just 9y. So then f of x plus y minus f of x over y is equal to 9y over y, which is equal to 9. So this means that the limit as y approaches 0 of 9, well remember, anytime we take the limit as y approaches something or as x approaches something, if it's of a constant, then the answer is just the constant. Right? There's nothing to plug that value into. All right, here we have find the limit. This is a right-handed limit, so we're talking about x approaching 2 from the right. So to find this, what we're going to do is we're going to put a value higher than 2, right? Because we're coming from the positive side. So if I say 2.1, then let's plug that in. What's the absolute value of 2.1 minus 2 over 2.1 minus 2? Well, this is going to give us 0.1 over 0.1, which is just 1. Because we know that our function is going to look like this. Okay? Circle like this, right? So this is 1, this is negative 1. So if x is less than 2, all of those values are going to be at negative 1. If it's greater than 2, it's going to be at positive 1. So this was positive 1. Number 12, find the x value at which f is not continuous. So that means that we need to find any discontinuities by setting the denominator equal to 0. So x squared plus 2x minus 35 equals 0. This is going to factor two numbers that multiply to be 35 but add to be 2, positive 7 and negative 5. That gives us that x equals negative 7 and x equals 5. So these are the values where it's discontinuous. It's either a removable or a non-removable discontinuity. And how do we tell which is which? Well, we know that that function is x minus 5 over this factored form, x plus 7 times x minus 5, right? So notice that the x minus 5 cancels out. That means that x equals 5 is removable. But the x equals negative 7 is not, because it doesn't cancel out. Number 13, describe the interval on which the function below is continuous. So if you look at this, there are no holes anywhere. That means there's nowhere, no real number, where that bottom is equal to 0. Because what happens if I set that equal to 0? X squared plus 2x plus 9 equals 0. Well, I know I can't factor it. They're not two numbers that multiply together to be 9 and add to be 2, so I have to use the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So here, b is equal to 2, so negative 2 plus or minus the square root of b squared, which is 4, minus 4 times a times c. So 4 times 1 times 9 is 36 over 2a, which a is 1, so just 2. So negative 2 plus or minus the square root of negative 32 over 2. All right, right there. We can go ahead and stop because the square root of negative 32 is imaginary. That means it's not real. That means there are no real zeros for that function, which means nowhere does that go to 0. Therefore, it's continuous over the entire real number line from negative infinity to positive infinity. 14. Now notice that this one has an asymptote. We also know that square root of x can't be 0, right? And that happens at x equals 0. But I also know that x has to be greater than 0 because I can't take the square root of a negative number, right? So that means that my interval is from 0 to infinity. And I can't include 0 because I can't have 0 in the denominator, right? If I let x be 0, then I wind up with 0 in the denominator. It has to be greater than 0, so that's my interval. 15, we want to verify that the intermediate value theorem applies. So first off, we need to look at it. Is it continuous? From 0 to 9? Yes. Does f of a less than c less than f of c, sorry. F of c less than f of b, or f of b less than f of c less than f of a? Are they in order, in other words? So let's find f of 0 equals 0 squared plus 8 times 0 plus 1 equals 1. F of 9 equals 9 squared plus 8 times 9 plus 1, which is 81, plus 72 plus 1, which is going to be 154. So does 21 fall between 1 and 54? 1 is less than 21 is less than 154. Yes. So we know that it does apply. So how do we solve it? We're going to say x squared plus 8x plus 1 is equal to the f of c, 21. So we subtract 21. We get x squared plus 8x minus 20 equals 0. So there are two numbers that multiply together to be negative 20 and add to be positive 8. Well, sure, you've got positive 10 and negative 2, which gives us x equals negative 10 or x equals 2. Which of these numbers, if any, are on the interval from 0 to 9? Only x equals 2. 16, we want to determine whether f of x approaches positive infinity or negative infinity as x approaches negative 2 from the left and from the right. So we want to say, what's the limit of f of x as x approaches negative 2 from the left? So if we're coming from the left, what are we approaching? We're approaching negative infinity. What's the limit of f of x as x approaches negative 2 from the right? So if we approach from the right, we're going to positive infinity. 17, determine whether the graph of the function has a vertical asymptote or a movable discontinuity at x equals negative 5. And then it says to graph the function using a graphing utility to confirm your answer. Well, can we factor this and cancel? This is x plus 5, x minus 5 over x plus 5. The x plus 5's cancel out, leaving only x minus 5. Since it canceled, it is removable. If it had not canceled, it would be a vertical asymptote. And then lastly, find the limit if it exists. So we're going to plug in 8, and what happens if we plug in 8? 8 minus 8 is 0 squared over negative 4 divided by 0. Means that we know that there's going to be infinity here, right? We know it has to be either positive or negative infinity. Now, since this number, no matter which value, which way we're approaching, if we approach from the left, which is what it asks us to do, then this is a smaller number than 8. So this is a negative number, but a negative number squared is still positive. So this is a positive number. The top number is negative, so a negative divided by positive means that our answer is negative infinity. And if you can't see that, just plug something into your calculator, verify it. So, and if you want to show me that work, negative 4 over, do, 7.999 minus 8 squared. Negative 4 divided by negative 0.001 squared. Negative 4 over 0.001, which is 0.000001. So negative 4 divided by that gives us negative 4 million. It's approaching negative infinity, right? And if you did an even smaller number, you'd see that that number gets even bigger. So you can see that it is approaching negative infinity. All right, that's the quiz. If you have any questions about this Chapter 1 quiz, please don't hesitate to shoot me a remind. Or if you need help on the sample test, which this is the exact same thing as the sample test, feel free to go ahead and bring it to class, and we'll talk about it in class.